Actually, I have a question.
Yes.
On the equation of 3,3. Like, I understand the equations, but I don't understand like what it's like. If I read it out, I don't understand how it actually makes sense.
There's a few equations. Are you talking about?
I'm trying to find the one. It's just the table one, all the table ones. I don't understand how.
Yeah, I disagree with them. We don't need a table yet, to be honest.
Yeah.
Some we don't need a table. Oh my god.
No,
But like,
there are some equations that tables will really help out with,
But
but a lot of these you don't need it.
it's more the equation part of it. I understand it. Like, I get the right answer.
Yes.
But like when you read it as a word equation, I guess, as a word problem,
Okay.
I'm trying to understand how it makes sense logically. And like,
So let's do this. Let's try out a problem from kind of each little section in 3.3. So let's say here's one in a drawer. There's what do you got, Jeff? In a cash drawer, there's $125 in $5 and $10 bills. Right, so I got $5 and $10 bills in a drawer, and there's 125 total dollars in there. Right? And then it says, the number of $10 bills is twice the number of $5 bills. How many of each are in the drawer? So what's the very first step in a word problem?
figure out what
You
you're
guys
trying
tell
to
me.
find.
Say again?
Figure out what you're trying to find.
Figure out what you're trying to find, what you don't know.
I thought he said it. I was going to say the same thing.
Oh, okay, well there you go. Yeah. So the English of it, right?
Right.
At the moment, I don't care about the numbers, I don't care about the relationships, I just care about what's involved. And of course, what's involved?
Division.
No. No operations, no math.
Oh no, math.
Just what's involved. How many players are there? Two things. What are they?
$5 bill and $10
The
bill.
number of each of those, right? So the number of $5 bills and the number of $10 bills. Let me stop for a minute, because the few people that have graded their stuff, some people are skipping the step, and then you don't know what the equation is supposed to be because you don't see the parts that go into the equation. You gotta not skip this step. This step is easy. It really is, because it's just English. Can you just read the problem and tell me what are the parts involved? Is there a length and a width? Are there people? Are there, in this case, there's a number of two different kind of bills. So write that down. Number of $5 bills, number of $10 bills. Everybody with me so far? And now you got to give them math names so it can start moving towards an equation. So what do you want to call, in fact, which one's going to be just X? That's the next thing you worry about. So it said the number of $10 bills is twice the number of $5 bills. This is number 171, by the way. The
So,
number of $10 bills is twice the number of $5 bills. So which one do you have to know first?
5.
The number of $5 bills.
The 5, why?
The number of $10 bills is twice the number of $5 bills. So if I knew the number of $5 bills, could I figure out the number of 10? Yes. I just doubled.
Not the other way?
Say again.
Not the other way?
You could do it the other way if you want to bring in a fraction, because in the other way, the number of $5 bills would be half. Half? Do you want to bring a fraction? If you do, you can.
I
Right?
don't want to.
If you don't want to,
I want to.
don't. So the number of $10 bills is twice the number of $5 bills. How can you tell what's supposed to be just X? One is something to do with the other one. So that step is amazingly important. Who is going to be just X? Because then everything else gets built off of that. So if we call this one X.
So, if we go off that, wouldn't it just be X equals X plus, or X squared, or 2X,
No.
which equals
Wait, stop.
125? Yes.
What in this problem says X equals
It just
2X?
said-
And how is that possible?
What?
How is it possible for x to equal 2x?
It's not, but I'm saying if you read it logically, that's what I'm trying to say is like, when I read it, that's what you immediately think, so like if I go to the table, it explains it better, but I'm trying to understand it.
The only time you would ever think logically that something equals something is if they say this is
You
that.
just said X is,
The number of $5 bills.
right.
So what's the number of
What I'm
10?
saying is,
Where
like,
is
X-
supposed to be equals.
Oh, I got you.
But, yeah.
Sometimes is just frickin' English, right?
Right.
How do I represent the number of $5 bills? With the
X.
symbol X. There we go. Right? And the number of $10 bills is how related to that?
That's 2X.
Yeah, okay. I like it. So right now, I'm not trying to build an equation yet. That's number one.
Yeah.
So the word is doesn't mean equals yet. I'm not trying to build an equation. I'm just trying to give these guys names so then I can build the equation.
Right. I get it.
I like it. Now, see if you guys get this. If I have X $5 bills, how much money is that by itself? If I have X, all right, listen. If I had
$5.
4 $5 bills, how much money is that?
20.
What'd you do?
4 times 5.
If I had 7 $5 bills, how much money is that?
35.
You with me? If I have X, because that's how many I got, ain't it? How much money is that?
5.
5x. Right? Every single $5 bill gives you $5. How many $5 bills do we have? X of them. So how much total money do I get from that? 5x. How much money do I get from each of these? They're all what kind of bills? $10 bills. So how much money does each of these give me?
10.
$10. And there's how many of them?
Twice.
2x. So I get
20.
10 times 2x.
Oh.
And then how much total money do I have?
25.
Yeah, so the total amount of money is equal to the amount of money I get from these guys plus the amount of money I get from these guys. So if the mistake I see, the most common mistake I see is people might get to this point, but then the equation they make is this. Can you see why this has got to be wrong? What does x represent? What does x represent?
The number of 5.
There we go, the number of $5 bills.
So you're multiplying the 5.
So what's this say? The number of bills plus the number of bills equals money. No. No. That would suck. You got 7 $5 bills, you got $7. Shit. I don't want that, right? So this can't be the equation because it's number of bills equals money. That doesn't make any sense.
Yeah.
So
I
when
think I was struggling with them both being X, and I didn't.
They're not both x.
Yes, they are. Both variables are X. What I'm trying to say is I was struggling with, like, in my head, it doesn't make sense that they would both be the same value. But
They're not.
I know.
Okay.
But
Oh,
that's
you
because
forgot
you
to
put the
bring
2
in the
in
5
front.
and 10.
Right.
Okay.
That's what I think I was
So
struggling
this isn't related to the value. This is just the number
with. Right.
of bills. So if I got X $5 bills, that gives me 5 times that much money. If I got 2X $10 bills, that gives me 10 times that much money. So it's money plus money equals money.
Right.
Cash money. So you should always stop. When you get the equation, make sure that what this side represents is the same as what that side represents. If that's money, this better be freaking money all over the damn place. Or else that equation can't be true. Equations actually have to make physical sense, believe it or not. So if you had no idea how to do this, what you can do for yourself is, give me a number of $5 bills. Just give me some number.
17.
17, sure. Let's go crazy. If I had 17 $5 bills, how many $10 bills would I have then for this problem?
34.
34. How would you figure out how much money this is?
34 times 10. Is
Yeah, 34 times 10 plus 17 times 5. Right? So what's your brain? Now look what I just did. You could do this for every word problem. You could make up a number that represents what you don't know. And because your brain will attack that much quicker than it's going to attack variables. So what do I not know? I don't know how many okay, let's just make up a number. And then I got that many $10 bills. How much money is that? Your brain is going to attack it. It's going to go, I got 5 for every one of these. plus 10 for every one of these. Well, where'd 17 come from? We just made that shit up. What should be there? X. Because I don't know how many there are. And where'd the hell did 34 come from? It came from 2x. Okay, maybe. That is completely allowed. There's nothing wrong with that, to get a feel for how everything reacts, how everything relates to each other. The brain will jump all over numbers all day, but when you give it x's and shit, you're like, what? So there's nothing wrong with giving yourself a value and seeing what your brain does with it. And then go, wait, what did I just do? And then write that down. Maybe. So that one was nifty because it had a couple layers to it, right? Had to bring the money in there somewhere. I like it. And now that equation should be relatively easy to solve. I don't think that was one you had to do, so I can't remember. Was it this one you had to do? Or no?
Similar to that.
All right. So let's just finish it out. It'd be 5x plus 20x. And then I would just divide by 25. X is 5. So what's that mean? I got $5 bills. And then how many $10 bills? 10. Let's check it. What's 5 times 5? 25 bucks. 10 times 10? 100. 125. There you go. It does what it's supposed to.
Question.
Yeah.
How did you get 25x? Because 5x times 2x? No.
All right. 5x. What's 10 times? You told me this earlier, I thought. What's 10 times 2? 20. So 5x plus 20x.
I thought when they're not like,
Stop. All right.
when they're not like terms, you cannot do anything with them.
No. I never ever said that. You need like terms in order to add and subtract, right? You do not need like denominators when you're multiplying fractions.
Or divide.
Some of you guys still think you're supposed to, but no. The whole idea there is to kill stuff, right? So here, what am I? Can I do 10 times 2x?
Yes.
Of course I can.
Of course.
Yeah. Could I do 10 plus 2x? Could I do that? No. But can I do 10 times 2x? Hell yeah. I don't know if you guys remember that. Why do we need LCDs? When I'm adding, subtracting, I need like terms. Well, when I'm multiplying, dividing, I do not need that. Multiplying, dividing is much less restrictive. Maybe. Do you guys know, do you guys get that, what I just said? Do you guys understand why? What does 10 times 2x mean? Stay with me.
$10.
No, come on, no. Just what's 10 times something mean? 10 times 2x in this case. 10 2x is doing what? No. Don't say 10 times 2. I love you guys. Hold on. Just stay with me. What's the old way to do like 10 times 8? You could write 8 10 times, right? So it means 10 of these. So 10 times 2x means write 2x added to itself 10 times, right? Are these like terms? By definition, they're like terms. They're all each other. That is one little reason why when I multiply, I don't need like terms. Not exactly like terms. But when I add, subtract, shit, yeah, I do. Okay. A little side note there, sorry.
That's nice.
Okay. I normally don't get what I talk about described in that way, but I like it. That was nice. Oh. All right, let's do another one. All right, we finished that one. Let's try another one out.
So the answer to that was 20 $10
I don't remember.
bills and
It was,
5.
no. It was 10 $10 bills and 5 $5 bills. It just was coincidence. That was 10 of 10 and 5 of 5. Let's see. Here we go. I don't remember what I assigned here. Probably this one. Let's do this one. Here we go. A school play. All right, they're doing Alien school play. Sold $550 in tickets. So they sold $550 worth of tickets. There were adult tickets. The adult tickets, the number of $8 adult tickets was 10 less than twice the number of $5 child tickets. Now, if you don't look at these word problems correctly, you quickly get buried underneath all the shit involved. You just do, and you know how that feels. Holy shit, the next sentence there's more shit, but the first thing I do, I look through this. I don't care about anything. Blah, 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 adult tickets. Blah, 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 child tickets. That's all I care about. Those are the two players in this problem, right? Ignore everything else except what the players are, and then write them down. Adult tickets, the number of adult tickets, and the number of child tickets. Have in mind this weird little, tiny little tickets. I'm child. There's something. Now I can worry. Now that I got the English part written, now I worry about the relationship. Which one is going to be just X? Let me read this again. The number of adult tickets was 10 less than twice the number of child tickets. So I have to know child tickets first. Number of adult tickets is blah to do with child. So what am I going to call the child tickets? X. You can use whatever letter you want to. Where'd it go? Oh. The number of adult tickets was 10 less than twice the child tickets. Yeah, big mistake I see here is this. That is a mistake. You will get negative tickets. It's like you just, I don't know what that means, to be honest. Somebody gave you tickets of their own. We're selling tickets. No, I got some for you. The shit? All right, anyway, sorry. So it doesn't make any sense. 10 less than twice this. I like it. And do you see how there was a point in this class where we just did that? I made you do just this because it was going to be a piece of this problem. So the more you can break these problems down into parts, each part is something we did before. And this is a lot like the dollar bill problem we did earlier. Right, the 5 and 10. Because what is it that I know for sure from the beginning happened? They sold 550 total bucks, right? So it tells me here, it says the number of $8 adult tickets was 10 less than twice the number of $5 child tickets, right? So the adult tickets was $8 and the child tickets was $5. Okay, let me stop for a second. If you can, please try to break these problems down into the very first thing, the English. The very next thing, what's just X? The very next thing, what's the other pieces? They build off of that. Now I'm figuring out what goes into the equation. I know it's a total amount of money. So I need money plus money to make money. How much money did I make off the kids? Total. Each ticket was $5, and how many kids' tickets did I sell? So I got 5x money. Hopefully not from the poor kids. Hopefully they paid for them. I'll get a job. And then how much money do I make from the adults? 8 for each one, and how many did I have?
2x minus 10.
This, so it's 8 for each one of these.
It makes sense.
You can
5
just go
times.
straight to 16x.
As long as you got the right stuff in there,
Yeah, 8 times 2, so 16x.
it's best to write it down for yourself before you try to start going further. Yeah. So what's the idea in each of these? I mean, if I told you that I'm going to sell these tickets, they're $20 a piece, and I sell 6 of them, how much money do I get off of that? $20 each, and I sell 6 of them. 120. 20 times 6. Are you guys with me? So all algebra does is it says, okay, we don't know the number. I'm going to do the same shit to it, though. What does X represent?
Number of tickets.
A number. that I don't know yet. So how does it act? Like any other number. If I knew how many kids' tickets I had, I would multiply it by 5 to see how much money I made. Right there. And if I knew how many adult tickets I sold, I do know. Here's algebra being really arrogant. I know exactly. It's 2x minus 10. That's how many adult tickets I sold. So how much money did I make off of them? 8 times that. So what is the most important step in this problem that people just skip? This step. This step right there. My God. If I don't write that for myself, I don't know what the parts are that I'm working with. And now this should be the easy step, right? Solving this bad boy. So now I can do. Yeah, so this is almost, I won't say boring, but this is the interesting part. Now this is just solving an equation. 550 plus 80. And then thankfully 21 goes in that even, so don't want to have any half kids running around or something. They're always freaky. Yeah. So what's that mean? 30 kids tickets? And? Yeah, 2 times 30 minus 10, 60 minus 10, 50 adult tickets. Thank God, you want those adults outnumbering the kids for damn sure. How do you check this?
50 times.
Yeah. 50 times 8 is $400 from the adults, and 30 times 5 is 150 plus 400 is 550. It works. You can always check your work at the end. Make sure it does what it's supposed to do. Let me see. Oh yeah. All right, let's try this one. Okay. So we got what they want from this one? More than you ever wanted? Okay. Here. We can't actually have this here, but we might as well pretend. Let's make some mimosas. Lauren is making 15 liters of mimosas. This is number 193. 15 liters of mimosas. Not my favorite drink, but they do in a pinch. All right. Thankfully, it's not just one order for somebody. Orange juice costs her $1.50 per liter. And champagne costs her $12 a liter. Champagne, I'll call it champagne. What did I say? $12 a liter. How many liters of orange juice and how many liters of champagne should you use for the mimosas to cost her $5 per liter? Woo! Holy shit. Huh? She's got some top-notch mimosas. I don't need the top shelf stuff. It's always nice when you get it. So she wants to combine some of these. So what is it I don't know? It says here, how many liters of each? How many liters of orange juice and how many liters of champagne? So it's very obvious. If you don't know what to make X, you normally just go right to the question, right? So my variables are going to be the number of liters of OJ and the number of liters of champagne. Now here's where things get interesting. Now watch. If I knew she was going to use 4 liters of OJ, can somebody tell me right now how many liters of champagne that means?
11.
Why 11? Because the very first thing I told you was she wants to make a total of 15 liters of mimosas. You guys kind of with me? They tell you this, right? Almost anytime they give you a total amount and then there's subgroups from them, it's going to work the same way. So like we just said, if I knew she was going to use 4 liters of OJ, that must mean she's going to use 11. How'd you get 11?
4 minus 15. Or 15 minus
15 minus 4. What if she was going to use 7 liters of OJ?
15 minus 7.
8 liters, 15 minus 7. So how much OJ is she using? I don't know. So how many liters of champagne then?
I don't know.
Yes, you do. When it was 4 liters of OJ, it was 15 minus 4, the rest champagne. Is everybody with me? Second. Again, pay attention to what your brain is doing. If I know she wants to make 15 total liters, she's got 4 OJ. What's left for the champagne? 11. Where did 11 come from? 15 minus 4. What if she had 7 liters of OJ? There would be 8. How'd you get that? 15 minus 7. How much OJ did we use?
X.
X. How much champagne then? 15
Minus X.
minus X. That's the rest. Anytime you have a total amount of something, one of these is going to be the total minus X, because that's what's left. What do these add up to be? Yes, you know. What's X
15.
plus 15 minus X? 15, right? If you add these, what do you get? You can, right? X plus 15 minus X is 15. And that's exactly what it's supposed to be, right? It's supposed to be a total of 15. Okay, maybe. So how much does it cost just for the OJ?
$1.50 per liter.
Per liter. So how much total?
150x.
Yeah. That's for the OJ, right?
Mhm.
How much for the champagne?
$12.
I didn't get that. Could you try again?
No. Who was that? Siri or no Siri, right?
My bad.
Sorry. All right, let me stop for a second. You guys, let's try this again. I want you got to get over the variables. I understand they're freaky, but just remember, they're just numbers. That's all they are. So if I knew I had 4 liters of OJ, how much is that going to cost me? 4 times $1.50, right? So how many liters of OJ do I have? X. So how much is that going to cost me? X times $1.50. So $1.50x. I want you to, do you see that? X's cannot do anything that numbers can't do. They can only do what numbers can do. That's what the shit they are. That's the thing you got to get over. If I knew what that was, that's exactly what I would do. I would multiply them. So what do I do when I don't know what it is? You do the same thing. You have to. So how much total does it cost me for the champagne? 12 times,
15 minus X.
yeah. It'll be 12 times the number of liters. The reason this is gross is because since there's a part of the problem we don't know, it's going to kind of show up in all these places, and it's going to make things look worse. But the actual fundamental things we're doing are the exact same. If I knew the numbers, I'd do the exact same thing. Why wouldn't I? Now here's the trick. She wanted this to end up being, where'd it go? $5 per liter. She wants this combined to make $5 per liter. So this is going to equal $5 per liter. How many total liters does she have?
15.
15. Money times, money per liter times liters, money per liter times liters, money per liter times liters. So both sides represent the same thing physically. So at least on that level, I know the equation makes sense. And this looks a little gross. It's got some fractions in there, but they're not that terrible, right? Hopefully, maybe. Now you would just distribute, multiply that. Get your x's together. Same stuff as before. Take a minute, just try to solve that. Finish that out. Oh, what is that? Yeah. Is that cool, everybody? You guys? There's only 1 decibel there. I don't have to kill it. Poor little thing. It's all low in the world. So what's that mean? Is everybody decent with that? Are you guys okay with that? You guys see? You might have done this in a different order than I did, but what's up? Everybody?
Why put the 180 first and then you put that? Okay.
Just because it was negative, it doesn't matter which order. If you did negative 10.5x plus 180, you're still right. Is that the right? I can put them either way. So I did 180, and then this minus this is negative.
Negative.
I think I'm just
10.5, yes.
naturally inclined to put a positive and then a negative. Less shit to write then. So what's that mean? Yeah, 10 liters of OJ, because I did this for myself so I know what the hell's going on. So I got 10 liters of OJ. So how many liters of champagne?
5.
Champion champagne. Heavy on the OJ there, but that's all right. Maybe. If you're sitting here right now saying, oh, I'm never gonna be able to do this shit, I'm just gonna skip these problems on the test, you gotta stop that, because it's gonna be this whole semester. There's gonna be word problems. I'm not saying this to make you feel bad or run screaming, but you have got to start to see how this gets put together. I know I'm a major geek, and you know this too, but I gotta tell you, the thing that amazed me when I first learned this was, as long as everything you do that goes into making an equation makes sense, then the algebra will get you to the answers. This is where I think you guys kind of lose connection with this. When I start doing algebra here, it's like, what does this have to do with this? It has everything to do with this. The algebra is what maintains the equality. So if the original equation is true physically, then the algebra will maintain that. It's so cool to me. All right. Did you guys see, all right, I have to, you guys saw the whole thing about the hurricane that was going, and our wonderful president decided to Sharpie extra. I don't know how you feel about Trump I don't give a shit. So Trump did some Sharpie shit saying, oh yeah, I was going to go to Alabama. Did you guys see that at all? Or are you, if you didn't, I almost feel jealous that you didn't see that. So later, they released this thing and it had, here's Florida, it's my poor little Florida, and they had all these different tracks for the hurricane to go. Every single one of these tracks, now, have you guys ever, I know we live in San Diego, I know you don't have to worry about hurricanes, I understand that. I lived in Florida, I lived in Virginia, hurricanes ruled my early life, right? There was always tape on the windows. Have you guys ever seen, you guys have seen the one with the little thing and it's got the cone that opens up? You guys ever seen that, right? And that's like its average path. Here's the behind the scenes that you don't get to see very often is there's different computer models and then they kind of average them together to get this. Every single one of these little lines is an equation where they took different variables at different amounts to create them because they don't know the weather has way too many variables. This is why we can't accurately predict it perfectly because way too many variables and all the variables interact, right? You've heard about the butterfly effect. It's not just a stupid Ashton Kutcher movie. It's a actual thing. All right, I'll stop. I'll bring it back. I just like to show you creating equations using real life observations help us do things. Can we ever be perfect? It's kind of nice that we can't be because life, you can't quantify everything in nature. This is why we can't get perfect agreement amongst all the computer models. All right, I'll actually stop this time. I'll stop. Yes?
I got stumped then. Where did you get 10.5 from 1.5x plus 180 negative 12x? How did you come up with
Oh, no. Are you cool? I distributed, right? You're cool with this one?
Right.
You cool with this one?
Yes, I got
And then what's my like terms? What's my like terms?
What? 1.5 and 12x.
1.5 minus 12.
Yeah. And the 0 is supposed to be after the 2 or after the 5. How did you get?
No, stop.
10.5?
How do you do 1.5 minus 12? You could do 12 minus 1.5 and then make it a negative, right? If you do 1.5 minus 12, that's what I got to do next, right? To get my like x's together.
Right.
So I can't really do that. I could do 12 minus 1.5 and then put a negative on it because the bigger one's negative, right? And what's 12 minus 1.5? 10.5. So then it's negative 10.5. Yeah. So it's just putting my like terms together. And again, if you don't want a decimal, you could multiply everything by what here to kill this? If you wanted to. Multiply by 10. But everything would have to get multiplied by 10. But then you wouldn't have decimals. So it's a nice little trade-off. Do big numbers scare you or do decimals scare you? You can pick, right? There's no third choice, unfortunately. Okay. I got that scary door and stuff from It in my head now. Which one do you want to pick? If you never saw It, all right. I don't know what to make it. Okay. So, let's do this.
You start doing triangle stuff.
Yeah, we're going to talk about that a little bit. We already did some geometry. The only thing we haven't done is Pythagorean Theorem. I'm not going to quite get there yet. I wanted to do percentages next. But you got to listen to me. I was hoping today that more people would have done more homework so we'd have more specific questions, right? You've got to get in the homework so you have some specific questions. Don't just find answers to the homework somewhere and then be able to check it off your list. That is not going to do anything for you, right? And like I just said, I'm not trying to scare you away. I'm trying to make you realize you can't just say, I'm okay with not knowing word problems, because it's a huge part of mathematics. It's not going to be just in one area. It's going to come up repeatedly, right? And again, not trying to scare you, trying to make you realize you've got to get this stuff now. Okay, maybe. All right, let's do this. let's get into percentages because they have their own little word problems. And then we can do a few more generic word problems and then we'll call it a day. At that point, I think it'll be time to head out. Percent word problems. Propane and propane byproducts. So, we did talk a little bit about percentages already. Percentages and fractions and so forth. But let me make sure you guys remind me what you know. 0.06 is what percent? 6%. I love it. What is 0.06 as a fraction? Yeah. This is the ones, this is the tenths, this is the hundredths. And why does that really kind of make sense? Because what's the percent symbol mean per 100? 6 per 100, 6%. Kick ass, right? Math does that all day. It's got to do that. It's got to come back to itself, or else the whole thing gets thrown out. So what is this one as a fraction? Let's go as a fraction first. Yeah, tenths, hundredths, thousandths, 10 thousandths. And then I show you this trick. How many decimals are there? 1, 2, 3, 4, right? And so there's going to be 1, 2, 3, 4 zeros. Why is that so nice? Because our number system is based on 10. So any number based on 10 will be easy in our number system. It has to be because it's based on 10 for some reason. I don't know. If we had 8 fingers, it'd be a very different number system. I'm not going to go there. What would it be as a percentage?
400.
Oh, wait. Are you saying 400ths? Yes. So how many times you got to move it over always to make it into a percentage? Twice. Why twice? Because percent is per 100. It's got 2 zeros. So one thing I like to tell people is the percentage number will always be bigger than the decimal number. Do you guys see that? 6 is bigger than 0.06. 0.04 is bigger than 0.0004, right? So that's a good little check. If you're switching, make sure that's true, whichever way you're going. So what would 412% be as a decimal?
412%.
No percentage. Make it a pure decimal.
412.
No, it's 412%, so it can't be 412 as a decimal. 4.12, because how many places, how many times you move it back? Once, twice. So the percentage number is always bigger than the decimal number. Here's something else. Decimal, percent, right? Write them in alphabetical order. See? If I want to change from a decimal to a percent, I move the decimals that way. Bam, bam. Bam, bam, right? If I want to change from percent to decimal, I move the decimals that way. Bam, bam. Maybe.